Good evening, teacher. My name is Carvajal Jose Martin and I talk about the WorkShop 8. In this case, we start with step 1. Open the software, add cards, then select the professional interface mode and activate Manager PV system. We need to check in the Adams card track in load. We need to put yes and then put OK. Step 2, create a full vehicle assembly, open assembly, then find the MSC tractor semi-trailer.ac, then open. The step 3, verify the system units. We need to check MKS. And the step 4, simulate full vehicle system. Full vehicle analysis, open loop steering events, single lane change. We need to put these values in the boxes. In this case, end time 10, number of steps 100, initial velocity 60, gear position 5, maximum steer value 60, start time 1, cycle length 2. In the guide tells you you need to vary the velocity, so we, for the test 2 and the test 3, we put the initial velocity 70 and 50 respectively. We make comparison with those 3 simulations. The color red and blue is for the velocity of 60, the pink and dark blue is for the velocity of 70, and the green and light blue is for the velocity of 50. In this case, we check the behavior of the axles of the trailer, because in the name of the curve is still inside wheel tire rolling state tire deflection trailer. So we check in this graphic or plot the behavior of the tires when the vehicle is it's moving on the road. So when the tire feels or pass an abrupt ground, we have the deflection in the time, and when or how much seconds the tire spends to return to normally. In this case, the deflection starts in the point 1.3 or maybe 1.2 until the time 4.5. And the step 5, animation analysis result. We need to select the plate tool. In this case, this is the select plate. And the step 6, plotting analysis results. In this case, we have 4 different curves. In the first curve, we have this behavior, and the behavior is when the velocity of 60. So we need to check the tire deflection in the rear, so in the last axle. So in the red curve and the blue curve, we have 2 different axes, so we have 2 different behavior. We check the color red, it's more than the color blue. So in this case, we have in my opinion, the color red or the second axle have more difficult to return, or more stress when the tire feel abrupt the ground. So in this case, the second axle have more difficult to return to normally, because in this graphic, the red curve take 1 to 3 approximately 3 seconds to return normally, but need more millimeters because the color blue starts in maybe 19.1 and the red curve starts in 19.4. For the second plot, we have the deflection, but in the trailer, not in this case is in deflection in the rear, but in this case is in the trailer. We have the forces when is the duration of the forces when the tire have a deflection. So in this case we have is the same like the before analysis, because we have the same time. In this case is 1 to 4 or maybe 4.5, but the length it's different, because in the previous plotting we have the starts in 19, but in this case starts in 18. So that's the difference, and in this case the red curve is more than the blue curve. So that is all for this plot. In this case the questions: how forces on tires affects chassis system. In this case we have these graphics. All of these force occur or affect the tire. So I can explain about the resistance to rolling force. This force affects the pneumatic and reduces the movement. That force also depends to the weight of chassis. The friction is more and depends of the coefficient friction of material that is made the tire and that of the surface. As a car makes a turn, the force of friction acting upon the turn wheels of the car provides centripetal force required for circular motion, as the centripetal force acts upon an object moving in a circle at constant speed. The force always acts inwards as the velocity of the object is directed tangent to the circle. Why would my tires wear so quickly? We have different reasons of the wears on tires. For example, your wheel alignment is out of manufacturer specification, or the suspension has a faulty component and the steering system has loose of or worn part. The braking system has excessive drag or a seized component. But for me the principle is the use of the vehicle, the number of hours the vehicle works, and the type of ground you are in contact with. If you don't select the correct tire for the operational context for your vehicle, your tires will wear out quickly, because we need to realize or make a study for the type of tire you can need or you must need. In the third question, there are so many brands and models to choose from. How do I know which one is best for me? You need to make a comparison for a lot of things in those cases. First of all, you need to specify your operational context, the type of ground your machine is contact with. The weather is important too, because when it's raining, the tread sites have an important work for optimum performance of the tire and the vehicle. We need to then you make a comparison with the price and the durations. For example, you got a premium tire, but after 3 months the tire is useless. In the other hand, a normal tire have a duration of 2 months. You can evaluate the cost of maintenance the 4 wheels and how much you spend in that maintenance. In this case, we need to comparison the type of tire, maybe the design, because these wheels is different to sun and is different to rain. We need to check the operational context, and the second point is the prices. If you spend a lot of money on premium tires, we need to comparison the duration, because if you spend less money with the normal tires or the basic tires, and the duration is maybe or similar, no, maybe or maybe the same for the premium tires. You need to choose the normal tires. But if you don't care the prices of the tire, you maybe choose the premium tires. Maybe, well, this all for me, and I finish with this video. Thanks.